Hi friends, in this class we are going to discuss about S-block elements. We know that the entire periodic table has been classified into 4 blocks: S-block elements, P-block elements, D-block elements and F-block elements. Now in this class we are going to discuss about S-block elements. The S-block elements have been classified into 2 groups. They are alkali metals and alkaline earth metals. And let us try to know which metals or which elements belongs to alkali metals. Lithium, sodium, potassium, rubidium, cesium and francium. So all these elements belongs to group 1. So the group 1 elements are called as alkali metals. And we know about the alkaline earth metals, that is second group elements: beryllium, magnesium, calcium, strontium, barium and radium. So these all elements belongs to group 2. So group 2 elements are also called as alkaline earth metals. See, in the S block, the differentiating electron enters into the S orbital. We know that there are 4 types of orbitals: S orbital, P orbital, D orbital and F orbital. So in the S block elements, the differentiating electron, that is the last electron, enters into S orbital. That's why these 2 groups, that means group 1 and group 2 elements, are called as S block elements. As the S orbital can accommodate only 2 electrons, 2 groups, that is group 1 and group 2, belongs to S block. So the general electronic configuration of S block elements is NS1 and NS2. NS1 is the general electronic configuration of group 1 elements and NS2 is the general electronic configuration of group 2 elements. So here, if you observe carefully, there are 2 tables given. The first table explains about alkali metals, that is group 1 elements: lithium, sodium, potassium, rubidium, cesium and francium, and their atomic numbers also given here. So the electronic configuration also given. So by this, if you observe carefully, we can conclude that the general electronic configuration of the first group elements is NS1, and similarly the second group elements are also. The general electronic configuration of second group elements also NS2. And now let us try to understand about group 1 elements, that is alkali metals. So these elements have 1 electron in their valence shell. So all group 1 elements have 1 electron in their valence shell. They do not occur in free state. That means these elements are highly reactive elements. These are not available in free state in the nature. These elements are collectively known as alkali metals. because their oxides and hydroxides form strong alkaline like sodium hydroxide, potassium hydroxide, etc. Here is a question: why group 1 elements are called as alkaline metals? So you can write this as an answer for that. Lithium is known as bridge element. This is one of the important bit here. So why lithium is called as bridge element? Because lithium acts as a bridge between group 1 and group 2 elements. So it has some similarities with sodium as well as magnesium. That's why this element is called as bridge element. And we know the valency of first group elements or alkali metals is +1. And in this, the francium has radioactive nature. In group 1 elements, the only element or the only metal which has radioactive nature is francium. This is one of the important point here. And now we are going to discuss about the second group elements, that is alkaline earth metals, that is group 2 elements. So these elements have 2 electrons in their valence shell. The element radium shows radioactive nature. So in the first group elements, francium shows radioactivity. In the second group elements, radium shows the radioactive nature. Valency of these elements is +2, as these elements have 2 electrons in their valence shell. They are ready to donate 2 electrons. That's why the valency of these elements is +2. These are good conductors of heat and electricity. So all the group 2 elements are good conductors of heat and electricity. Flame coloration. That means when these elements were burned in presence of air, they will give some colors. Beryllium and magnesium do not impart any color, as their atoms are small and require higher energy for excitation. That means when beryllium and magnesium are burned in presence of oxygen, they won't give any color. When calcium is burned, so it will give a brisk red colored flame. But when strontium is burned, it will give us crimson red colored flame. When barium is burned, it will give us grassy green colored flame. And when radium is burned, it will give crimson color. Thanks for watching. In the next video, we discuss about p-block elements.